Okay, guys, this is just chapter 4 practice, and it's been a while since we've done some of it, so I'm going to go over these problems, and this will be here for you to look at over the next couple of days. Number 1 is what we actually did in lesson 1, where we're going to solve the system by graphing. So I can see, I'm going to do a couple different colors here. So this one I will be doing first, and I can see, let me make it a little bit bigger. Here we go. My y-intercept there is positive 2. I do need to draw my x and y-axis, don't I? I didn't realize that was not on there for me. So there's my y-axis. There's my x-axis. And remember, we want to be as precise as possible on these, and that is crooked, I say. As I say, I know we need to be as precise as possible. Because that's where we're getting our solution from. Here we go. Now, let's try that again. My y-intercept I can see is 2. So that's going to be here. And my slope is 1 over 3. So rise over run is going to be 1 over 3. So up 1 and then over 1, 2, 3. I know that's going to put me here. So there's going to be my first line. Again, I'm going to try to make that as straight as possible. That didn't work out too well for me. So let me try that again. I'm going to put a third point just so that I can get my line correct here. Okay, that's as good as that one's going to get. So that was my first line. Then my second line, same thing. This one's also not so bad. For this line, I can see this time my y-intercept is negative 2, so that's going to put me down here. My slope is going to be negative 1, so I want to make sure and go down 1 and right 1, or up 1 and left 1. And that's actually going to, ooh, goodness, sorry, hand got bumped there. Okay, so again, trying to be as precise as possible, which actually works out for me pretty well because I can see here that those two lines happen to intersect at this point right here, which makes it the solution. That is the point negative 1, 2, 3, and positive 1. So the solution would be negative 3 and positive 1. So solving by graphing. Number 2, does the system have no solution or infinitely many? Honestly, whenever they give you the two equations without graphing, the easiest way is to just change them into mx plus b form. So I can see here that obviously the second one is already there. To get the first one there, all I really have to do is subtract that 2x from both sides, right? So if I move that over, this is going to turn into y equals negative 2x plus 2. So looking at my two equations, right? So here's one equation. Here's the other one. They're obviously not exactly the same. So it's not infinitely many solutions. In order for it to be infinitely many solutions, they would have to be exactly the same equation, and they're not. I can see that they have two different y-intercepts, right? This one has a y-intercept of 2. This one has a y-intercept of negative 1. However, they both do have the same slope, which means they're going to be parallel, and therefore they have no solution. So that's the answer to number 2. Number 3, they just want us to estimate the solution of the system by looking at the graph. And I can see here that they intersect approximately here. That looks like that's at about 1 and maybe 2.5. They are counting by ones on this graph. So that, again, that it says estimate. So maybe around 1 and 2.5. So that's number 3. Okay, number 5. So number 5, number 6, number 8, all of the rest of them except for the inequalities maybe. You feel free to do substitution or elimination. We talked about how whenever it comes test time, I'm not going to make you choose one way or the other. I would definitely personally do substitution on this one because I can see that one of the equations already has y equals something, and I can just go and work this one out. So that's what I'm going to do. Again, y equals, so I'm just going to take that and I'm going to substitute it right here for y. So I'm going to end up with negative 5x plus 4 times 1/8 x minus 1, right, that's the value of y, equals negative 13. And then I'm just going to solve it. This one, of course, does have a fraction, but it's okay. You guys have calculators, and fractions really aren't that bad. So when I distribute 4 times times 1/8 is 1/2, so that's going to be 1/2 x. And then 4 times minus 1 is minus 4. I just used the distributive property right there. I will have to add these two. Feel free to leave it as a fraction here or a decimal. That's going to give me what? Negative 4.5. So that's going to be negative. I'm doing this in my head. Okay, guys. So I'm having to do it the way I can do it in my head. That's going to be negative 9/2 x minus 4 equals negative 13. Again, feel free to change that to negative 4.5. Adding 4 to both sides. So if I added 4, I get negative 9/2 x equals, what is that? That's negative 9 if I add 4 to both sides. And then you can either divide by whatever's in front of x. Again, in this case, I will be multiplying by the reciprocal. So that's going to be a negative 2/9. I don't have a calculator, so you guys are just going to have to bear with my fractionness. Sorry. Not sorry. So x equals, and that's just going to be 2. So that's the x value is 2. That's what you should get regardless of using decimals or fractions. And then to get the y value, you're just going to take that 2 and you're going to put it back into that first nice equation. Let me change colors here so I can't scoot over anymore. Sorry. Here, I can do it right here in this blank space over here. I'm doing y equals 1/8 times 2 minus 1. Again, I just substituted it in that top equation. An 1/8 times 2 is a 1/4. A 1/4 minus 1 is negative 3/4 or negative 0.75. So that means the solution to number 5 is the point 2 and negative 3/4. Nice. I'm just checking my math really quickly to make sure that does work out. And it does. Okay. All right. Number 6, same thing. I would definitely do substitution on number 6 because just like number 5, it already has y equals, right? So y equals 1/3 x plus 2. So that means I'm going to be substituting it in for the value of y. So I get negative x plus 3 times 1/3 x plus 2 equals 6. Just put the 1/3 x plus 2 in for the value of y. I'm going to use the distributive property again, so this time I get negative x plus 3 times 1/3 is 1, and then 3 times 2 is 6 equals 6. So I can see here this is going to end up being one of the special ones because whenever I add or combine negative x plus x, that's 0. Like it goes away altogether. I have no x values left. And what I'm left with is just 6 equals 6. And 6 does indeed equal 6. That's a true statement. So that means this one happens to be one of those infinitely many solutions. These two lines are exactly the same line. So they would completely intersect in every point. So that's why there are infinitely many solutions. All right, number 7. We did a couple of these like this. Where we know we have a couple of things happen. So Henry, he's selling rings and he has expenses, right? He's got money coming in, he's got money going out. Excuse me. So we have to let our x and y value equal something. So in this case, what I'm looking for is how many rings he's trying to sell. So I'm going to let me change colors again, try not to let this blend together. I'm going to let x be the number of rings. And in this case, y is going to stand for a dollar amount, which could be, again, we've got revenue and cost, right? So he sells them for $8 each. And that's the only money he has coming in, $8 per ring. So his money he has coming in, y equals 8x. But the money he has going out is $1.50 per ring plus $91 for supplies. So that equation is going to be y equals 1.5x plus 91. Our two equations, one for money coming in, one for money going out. And again, I would definitely solve this one using substitution. I'm actually going to scoot down a little bit and do this one down here because I'm obviously running out of room. I'm going to do this one down here. So again, the two equations were y equals 8x and y equals 1.5x plus 91. Okay, so this one, like, they're already both equal to y. So I'm just going to take the two values, this one and this one, right, the two expressions, and I'm going to set them equal. So I get 8x equals 1.5x plus 91. So I'm just going to solve this one. This one's pretty simple, other than the fact it has stupid decimals in it, and I'm going to have to use my brain. Actually, I'm going to cheat and use a calculator here in a second. What is that? 6.5 x equals 91. Do I have a calculator on this sucker? Dagnabbit. I mean, I have one, but I don't like using it. Alright, so 91 divided by, stupid odds. What was it, 6.5? So 14. So x equals 14. And if you remember, x stood for the number of rings that he had to sell. So in order to, that's what it says here. It says, how many rings does he need to sell for his revenue to equal his expenses? So he's breaking even, right? We did that. So the correct answer would be 14 rings. Okay. All right, now number 8. Number 8 is, these are both in standard form. So since they're both in standard form, personally, I would choose to do elimination. Now, I will have to multiply both of these, or one of these. I'm going to choose to make the y values the same because one of them's already negative and one of them's already positive. Plus, it would be really easy to make that 2 a 4, right? Just multiply times 2. So I'm definitely going to just take this and do times 2. Alright, so the top equation is just going to stay 5x minus 4y equals negative 10. I'm not going to touch that top equation. And the bottom equation is going to become 6x plus 4y equals 32. Make sure you are multiplying each of the terms times whatever it is you need to multiply by, in this case 2. And now I can add them together because my y's will be eliminated. Hence the term elimination, right? 5 plus 6 is 11. The 4 and 4 go away, right? Because it's negative 4 plus 4, that's 0. And then negative 10 plus 32 is going to be 22. So that means the value of x is just 2. See how nice that was? I just love these. These are so nice to me. Whenever I need to find the value of y, you can choose to plug it in either one of the equations. It doesn't matter which one. I'm personally going to choose to plug it into the second one simply because there are a lot of positives in that problem. So I'm going to do that over here to the side. That's going to give me 3x plus 2. Oops, guys. Sorry. The value of x is 2. So that's going to be 3 times 2 plus 2y equals 16. I was about to plug it in for y by accident. So again, I plugged it in for the value of x here because again, I know x is 2. So that's just going to give me a really easy little two-step equation, right? Because 3 times 2 is 6. Subtract 6 from both sides, you get 2y equals 10. And then divide both sides by 2, you get y equals 5, which means the solution to number 8 would be the point 2 and 5. 2 and 5. So let's really quickly check that. That's 10 minus 20. That works. And then 6 plus 10. Yep, that's the solution. So that's number 8. Number 9, same thing. I can see here I have 2 equations in standard form. I'm going to do the same thing I did on the last one. I'm going to choose to make the y's the same because, again, one's already positive and negative, and it'll be really easy to make that to a 4. So I'm going to do that. So I'm going to multiply this. I mean, it would be really easy to make that to an 8 by multiplying times 4. You guys will have to excuse me. It's kind of late. The top equation is going to become 20x plus 8y equals 24. And the bottom equation is going to stay 4x minus 8y equals 0. Listen, guys, it's totally okay to have 0. Don't freak out. 0 is a number. Okay, so I can line those up and add them. 20x plus 4x is 24x. Again, the y's go away. 8 minus 8, that's 0. And 24 plus 0 is 24. So that means the value of x is 1. To find the value of y, I would need to go back and plug that in. This time I'm gonna choose to put it into the second equation just because I have a 0 in that equation, and you guys know how much I love 0. So that would give me 4 times 1 minus 8y equals 0, which is 4, right? 4 minus 8y equals 0. So I would need to subtract 4. Ooh, this one's going to give me a fraction. Negative 8y equals negative 4. If I divide by negative 8, I get y is 1/2. So the solution to this one is the point 1 and 1/2. Again, let me check my solution really quickly. 5 plus 1 is 6, absolutely, and 4 minus 4 is 0. So that is a true solution for number 10. Okay, number 11 is really, really super duper similar to number, what was it, 7. You got cost, but this time you have cost again. Your two different things are drinks and sandwiches, right? Excuse me. So I'm going to let x be the number of sandwiches. And I'm going to let y be the number of drinks, not number of drinks and number of sandwiches. Again, guys, I apologize. It's kind of late and I'm not awake. It's not the number. We're looking for the cost, right? It would really help if I actually read how much does one sandwich cost. That's what I'm looking for is cost. So x is the cost of the sandwich. And I'm going to let y be the cost of the drink. Now, I know they don't ask me for that, but I kind of need to use it because they give me information for that too. So 6 sandwiches and 4 drinks is $53. 4 sandwiches and 6 drinks is $47. So it just gives you two equations. Neither of them are pretty. That I can use using, in this case, I'm going to use elimination. Because substitution would definitely not be fun on this one. All right, 6x, 4y, 53. Boop. 6x, 4y equals 53. And the other one was 4x plus 6y equals, I believe it was 47. Was that correct? Yeah, 47. All right, I will have to multiply both of the equations on this one because there's not a nice number to multiply 4 times to make it a 6. So I'm going to make them both a 12. I'm going to make my y values go away because I am looking for the cost of the sandwich, and x I let represent the cost of the sandwich. So if I don't have to find the cost of a drink on this. So if I make the y's go away, that's less work on me. So I'm going to multiply this equation times 3 so that make that 4 become a 12. I'm going to multiply this equation times a 2 to make this a 12, but I'm going to make it a negative 2 so that it would make it a negative 12 and therefore will be eliminated in a second. So that's going to give me the top equation. It's going to change into 18x plus 12y equals, what is that, 159? And then the bottom equation is going to turn into negative 8x minus 12y equals negative 94. Yep. And there we go. Just add it up. That's going to give me a 10x. That's 0. What is that? 65? I believe so. 65. Yes. Okay. And then divide both sides by 10. So you get 6.5, but we know since we're talking about money is the cost of the sandwich, the answer is $6.50. So one sandwich is $6.50. I do not have to find the cost of a drink, but if I could, it would just be the value of whatever Y was. So that was number 11, $6.50. All right, number 12, graphing an inequality. Okay, so this one is just the one line thing, very similar to number 1 whenever I'm graphing the line. I do need my X and Y coordinate here. Okay. So I can see my y-intercept is 4. 1, 2, 3, 4. My slope is negative 2, so negative 2 over 1, so down 2 and right 1. Again, I'm going to go a couple more just because my drawing tool on this is not the most user-friendly, and it helps me to have more than one point. There we go. Oh, wait. It's a dashed line. So I can't use my handy dandy little hold it down, make it pretty thing. I have to make it look not nice. All right, there we go. It is a dashed line because it is just less than, right? That means that those points on that line are not as part of the solution. I do need to graph either on the left or the right. Remember how we talked about, let's be careful about making generalizations. If you got it, great. If not, let's test that point. I always like to use that because that always works regardless. Of course, you know me. I'm going to test the origin since it's solidly there on the left side of the line. So that means I would have 0 is less than negative 2 times 0 plus 4, which is going to give me 0 is less than 4, which happens to be a true statement, right? So that means that 0 is on the side where the solution needs to be. So my shaded side will be on this side of the line. And that's number 12. Number 13 is just that backwards, right? We're looking for the equation this time. They were nice and gave me multiple choice on this, but well, first of all, let's look at multiple choice. Let's talk about that for a second. I can see that it is a dashed line, so immediately I know that C and D cannot be answers because those are equal to's, right? Those two would have to be solid lines, so definitely not a solution. Also, I can see that the only difference between A and B is A is a less than sign and B is a greater than sign. So I know that the y-intercept is negative 3. I know that the slope is negative 1 because those are the only options that it gives me. I just have to decide, hey, is it less than or greater than? So I'm going to choose a point in the solution area, which the origin happens to be there. So I'm going to plug that into the equation and see what it's going to give me. So 0 for the y value. And I'm going to leave like a blank spot, right? 0 and then negative 0 minus 3. Obviously negative 0 is not a thing. So I have 0 and then some sign, and that's a negative 3. So is 0 less than negative 3 or is 0 greater than negative 3? Of course, it's greater than negative 3. So that means that the solution would need to be B because that would make that a true statement. And again, that is in the solution area. Let's see, which one are we doing next? Okay, so 16 and 17 are like what we did yesterday. Where I'm just going to graph two of the systems and it's going to turn out like it's going to turn out. All right, so let's go ahead and draw our X and Y axes here. Both of these are in standard form, so I'm going to do the same thing as I did yesterday. I'm going to use the X and Y intercepts because that is definitely the easiest way to do both of these. And you get pretty nice stuff here. All right, so I'm going to do the first equation in purple because I want to. All right, now remember, whenever we're graphing, we treat this as if it's an equal sign, right? I need X equals 0, so Y equals something. And then X equals something when Y equals 0, right? That's going to give me my Y-intercept and my X-intercept. So if I let the X equal 0, that means this is going to go away. And I end up with Y equals -1. Well, that was pretty easy. Right? I didn't have to divide anything. On the other side, if I let Y equal 0, that means this is going to go away. Right? And I just have negative X equals -1. So if negative X equals -1, you would need to divide both sides by negative, right? You need that to be a positive. So that would be a positive X equals a +1. So that one wasn't too bad because I didn't have to divide anything really. So 0 and -1 is going to be here. And 1 and 0 is going to be here. This one is a solid line. Oh, geez. Okay, I'm going to try to make this as pretty as possible. Sorry. It's a little off, but it'll do. Okay. So I'm going to use the origin to check because I can see the origin is obviously right here, right? So if I put a 0 here and a 0 here, I get 0 or -0 plus 0 is less than or equal to -1, which is 0 is less than or equal to -1. That is not a true statement. 0 is not smaller than a negative. So that means for my purple line, the shaded area, let me do it in purple since I'm sticking to that, is going to be on the side where 0, 0 is not, right? So that's going to be on this side for the purple line. Okay, let's now look. I'm going to do the next one, and I don't know, let's do this one in green. Okay, so the same thing for this one right here. I'm going to have X equals 0, Y equals something. X equals something, Y equals 0. Those are going to be my two intercepts. So if X is 0, this goes away. And I get 2Y equals 4. So that's just 2. And then if Y is 0, that goes away. And I just have X equals 4. And see, so that one's not so bad either. I didn't end up with any yucky fractions or decimals. So 0 and 2 is going to be here. And 4, 1, 2, 3, 4, and 0 is going to be here. This is another solid line. It does have an equal to underneath it. So I'm going to, oh, wow, gosh. Thank goodness for that straight line tool, right? Yeah. All right, so there's my line. And again, I'm going to choose to check the origin. It is obviously well below this line, right? It's right here again. So again, I'm going to put a 0 here and a 0 here. So it's going to give me 0 plus 2 times 0 is greater than or equal to 4. Or 0 is greater than or equal to 4. That's another false statement. 0 is not bigger than 4. So that means on this one, again, not where the shaded area is. So, oops. So if I were to shade this one, it's going to be up here. Which means my actual solution is that area where the purple part and the green part overlap. So if I want to be really particular, that's going to be right here. It's going to be this region right here. All right, number 17. Gotta love me some multiple choice. I'm going to use the heck out of this thing. Now, we didn't talk about vertical and horizontal lines yesterday, but we have graphed vertical and horizontal lines. And they're actually super duper easy on a graph. So let's look at this one. This is the line, obviously, x equals -1 right here. I can see that that goes through -1. Let me make this a little bit bigger. And it's pretty obvious that it's -1 because if you look at your multiple choice answers, every single one of them is x and less than or equal to -1. So again, using multiple choice to my advantage, I know that A and B cannot be correct solutions because every single one of these is just a less than or greater than, and both of the lines in my graph happen to be solid lines and not dashed lines, so I don't even have to worry about those two at all. Okay, so, whoops. So that vertical line there is definitely x is less than or equal to -1. I don't have to worry about that one. It's the other line that I need to worry about. It looks like they made it pretty easy for me. I say that and now I'm about to take that back. Alright, so here, let's look at that. Let me change colors here, sorry. Obviously the y-intercept is 2, right? They give me that choice on both of them. Everything is a solid line here. Look, if the slope was -2, I go down 2 and right 1. Right? If this was indeed my slope, I would go down 2 and right 1. Guys, that's this line. That's not the line they give me. Whereas if the slope was -0.4, now you guys know how I feel about decimals, but like in this particular case, I'm gonna get on my soapbox for a second. -0.4, that's the same thing as -4/10, right? That's how we read that. -0.4 is -4/10, which is -2/5. If I went down 2 and then right 1, 2, 3, 4, 5, right? So this is one of those cases. Fractions are definitely better. So that's why C is the correct answer for this one, because that is the one that matches the graph better. All right, last one. 18. It's really just like the sandwich and drink problem. But in this case, you have adult tickets and child's tickets. Literally almost exactly the same problem. I'm gonna let X be the price of the adult ticket. And I'm gonna let Y be the price of the child's ticket. So here I can see in my first sentence it says 2 adults and 4 children is a total of $48. And then in the second sentence it says 5 adults and 2 children is $64. So you just end up with an equation, and this one's actually easier than the sandwich one because I can make those y's of 4 pretty easily. 2, 4, 48. I'm going to come down here and do this one. So 2, 4, 48. What was the other one? 5, 2, and 64. 5, 2, and 64. So yeah, this is just another elimination problem. I'm gonna make the y's the same. So I'm gonna multiply the second one times a -2. So the top equation is going to stay 2x plus 4y is 48. The bottom equation is going to become -10x minus 4y equals -128. Again, multiplying all of that this time, -2 on the bottom. So whenever I go to add them, these go away, which is what I wanted to happen. I have -8x equals, what is that? Well, it's late and my brain is off. -80? Yes, -80. Correct, yes. So that just means x is 10. So that means an adult ticket is $10. So if I wanted to find the price of a child's ticket, I would just take that 10 and plug it into one of the two equations. Doesn't matter which one. I'm going to choose to, oops, I keep doing that. I'm going to choose to put it into the top equation. So that would be 2 times 10 plus 4y is 48. Right, 20 plus 4y is 48. And then just going to solve that. It's a pretty easy little two-step equation. Now I get 4y is 28, or y is 7. So that means the price of a child's ticket is $7. So the correct answer was $10 and $7. All right, that is a very quick review of substitution, elimination, graphing systems, and inequalities. There you go.